Hey everyone, this is Dan. I got a lot of requests on what was the easiest way to set up Linux CNC using a Raspberry Pi parallel hat along with a 5-axis breakout board. So in this video, I'm going to show the simplest way that I could think of to set up Linux CNC. Here is a fresh image of Linux CNC. This is for the Raspberry Pi 5. For both Linux CNC Raspberry Pi versions, the password and username is CNC. I'm going to go ahead and log in. This is the first time this is booted up, so when I click on the start menu there, I have Linux CNC as an application, and when it first comes up there's a bunch of simulators that we can select from, but really I don't want any of those for my machine, so I'm going to hit cancel and close that out. The first thing I really want to do is go to the terminal editor, and I'm going to type in a command to get the X archiver. This will allow me to unzip the zip file from the website. I'm going to close that, and we are going to set up our default machine. So inside the CNC menu, I'm going to do a Linux CNC step config wizard. I'm going to go ahead and hit start, and I want to create a new configuration. The machine name, you can put anything you want here. So I'm going to just type CNC machine, just for something to put there. It is an XYZ machine, and the default measurement I want to be millimeters. The driver type I'm going to leave as other, and the rest of these really don't matter at this point. It's set for one parallel port, and really that's all we have. So I'm going to hit forward. All of this will get replaced by the HAL file that we're going to download off the website. Let's see, screen axis is the kind of the default CNC user interface. Let's see, the x-axis information here is really machine dependent, so we can go ahead and modify this in the INI file later. The same goes for the Y and Z axes. The spindle we can again modify later, but the interesting part here is that the speed, let's say it's 100 RPM at 20% duty cycle for the PWM, and 800 RPM for an 80% duty cycle. So we'll go ahead and modify those later. Alright, we are all done. Yes, I want to quit. Okay, if we go to the file system, what we're going to notice is that the Linux CNC folder is now in the home folder. And if we go in there, we have configs and CNC machine. This was the name that we put for the machine setup. If I go inside there, I have the INI file and the CNC machine.hal file. So these are the two most important files that we will be modifying by hand to really fine-tune the setup. So I'm going to put that off to the side, and I'm going to go to the Byte2Bot website and download the HAL file. Alright, here are the links to the Raspberry Pi 4 and 5 HAL files. I'm going to go ahead and download the HAL file, and I'm going to download the example folder as well, because there's some interesting things in that I want to show you. Since we already downloaded the X archiver, we can go ahead and unzip this here. I went ahead and put those into the downloads folder. So here is the folder of what I have as a working machine that you can look at and compare against if you run into difficulty getting your machine set up. Alright, so the CNC machine.how file is what LinuxCNC created, and we are actually going to rename that to something else. I'm actually just going to put the postfix of old at the end, rename it. Now, we downloaded the example HAL file, the CNC router pi5.hal. I'm going to copy that and I'm going to paste it into the folder into the CNC machine folder that we created for the new machine configuration. And I want to rename this to the CNC machine.hal so that this file can be used instead of the original one that was created. Okay. Minimize that. So now we have copied the HAL file from the Byte2Bot website. We've renamed it to the same machine name, and so when we open up LinuxCNC, it will use that file, and we can see it right here under My Configurations, CNC Machine. We're going to go ahead and open that. So right now I am able to not able to do anything. Clicking on the emergency stop button should keep it, or should allow it to start working, but I am not able to click on that button for some reason. So what I've found though is that the configuration, or the HAL file, has a setting in there that might help make this a little bit better. I'm going to go ahead and expand that. So down at the bottom is going to be the estop, net estop-ext. There are two different lines that you can use. So I'm going to comment out one and use the other. I'm going to go ahead and save that and close LinuxCNC and reopen it. Alright, let's see if that made any difference. Yes, I'm able to turn off the estop. So when I press this button, I do have the ability to move the machine with the arrow buttons. It goes pretty slow right now, and that's part of the default configuration of the machine, but I am able to turn on the spindle and stop it. So by default, everything is sort of working. Now what I haven't mentioned so far is that when I press the right arrow key, the machine is actually moving left. And when I press left, it moves right. Even though LinuxCNC thinks it's moving left, it's really moving right. Same thing Actually, the y-axis does not need to be reversed, but if I press the page up, my machine moves down. So I'm going to have to reverse the x and z axes. So reversing those is fairly simple in the INI file. So if I open that, this file has everything machine specific. So down at the bottom is where each axis has its information. Now, in order to reverse the direction on this, you put a minus sign in front of the scale factor. So if I reverse the x and the z, I'm going to save that. And I'm going to go back and restart LinuxCNC. Now when I move or press the right arrow button, my machine actually moves to the right, just like the little display is showing on LinuxCNC. And when I press the page up, it actually moves up. So we've got the axes running in the correct direction now. So there's other interesting things inside the INI file that are worth mentioning. And there's some things that I like to add to it. But first we're going to talk about the scale factor itself. Even though we put a minus sign in it to reverse the direction, what this scale factor is really depends on the number of steps per revolution for your stepper motors and what your stepper drivers are configured for, whether they're full step, half step, eighth, 16th, 32nd of a step. They're based on that, you're going to set your scale factor differently, so your machine moves 1 millimeter when you tell it to move 1 millimeter. The other thing that I wanted to mention is easiest to look at by using the zip file that we downloaded earlier. So in that zip file, I have my CNC router.ini file. I'm going to go ahead and open that up and show you what I use for the homing. Now when I home my machine, I would like the z-axis to move straight up and find its home, then the x and y axes to move to their home position. So I'm going to add this information here to the machine INI file. I can go ahead and replace the home offset. So the home offset parameter is set to 0.0, so that means when it finds the switch, it's at location 0. The search velocity is how fast it moves towards the home switch initially. The latch velocity is when it hits the switch the first time, it will move away from the switch and then supposed to move slow back to where the switch activates again. So the latch velocity is when it moves away from the switch, and the final velocity is when it moves back towards the switch. These can be a little bit higher if you want, depending on how fast you want to do the home. But the home sequence parameter is set to 0 means I want to do this first. If I go back and copy the information for the y-axis and put it in the machine INI file, you'll notice that it's all pretty much the same data except for the home sequence is set to 1. So when you press the home button, it will do the Z first, then the X, and we're going to go ahead and copy the, or sorry, it'll do the Y. And I'm going to paste the X in there as well. So you'll notice that the X information is actually the same as the Y. This means that with the home sequence set to 1, it will home both the X and Y axes at the same time, which is fine for me because I've got my Z axis all the way up out of the material, and it can move in X and Y at the same time. When it hits the switch, it will stop that axis, or actually it'll hit the switch, move away from it, and go back and hit it again. That will occur for both the X and Y after it's done with the Z. So this is kind of a very useful file for us, this INI file. You can change a lot of other parameters in here. I'm going to go ahead and change the acceleration to what I had in my original file. So I've got my acceleration set to 100 and max accel set to 120. So I'm going to set those again here for each axis. I probably won't do this on video, but it's just a little bit of tweaking that can be done for your machine. Alright, so we've basically set up the INI file as as best as we could. The axes are all working in the correct direction. Obviously we're going to have to tweak the scale factor, and I'll do that later. But really we should be able to start the fine-tuning aspects of it. I use the CNC parallel hat to control the 5-axis breakout board. And on that, I've got a MOSFET that controls the spindle on my machine. So there may be different configurations that you want to try based on your spindle and how it works. So I'm back in the CNC machine.hal file, and the spindle outputs section. There's a lot commented out, but really the PWM is, I think, probably going to be one of the most common output types. So right now I've got the scale set to basically like 100%. PW or duty cycle on the PWM will give me about 1800 RPM. This is kind of a guess. I just picked a number and put it in. If I get a tool to measure the RPM, I'll go ahead and fine-tune this later, but this seems to be a fairly good number to start off with. If you use a spindle that has its own spindle driver, like a 3-phase motor driver, you can also use the PWM for that as well. So I'll put a wiring diagram on the website that shows how to wire that up if that's what you're after. There are possibilities of using a 485 interface to control a VFD for your spindle. I have not tried those, as I don't have a VFD on my machine. So hopefully if you do need to use that, there is a 485 interface on the parallel hat. Please let me know if you get that working, because I'm interested in knowing how that works. I've got some sample script information here that I pulled off the internet, but without a VFD I'm unable to try it. So we can work on that if you need it. So please let me know. I know LinuxCNC is super powerful and just about anything can be done. I hope this video gave you a few pointers how to get up and running as fast as possible. If you found it useful, please hit the like button so it can be suggested to others who may need some suggestions as well. Thank you so much for watching.